Greetings, this is Mr. Caslin. We're going to continue working on solving a system of equations. That's just math language for multiple equations with multiple variables. In these problems we have two equations, two variables. If we were to graph these two functions, remember these functions are linear. If you graph these two lines, the solution we're going to find mathematically is the same solution. That would be the intersection of these two lines. Okay, so you could graph these and find the intersection, but we're going to show you how to do these mathematically. Now, there was another video on substitution. That's one method. The second method is called elimination. Some teachers call that linear combination. All right, now I prefer this method. You watch the math on this should be easier and the steps are less. Okay, so if you're given the choice, I would look to do elimination. Now, when you're doing elimination, you want your equations in standard form. ax plus by is equal to c. Okay, because we're using this concept that you're allowed to add two equations together. Okay, in this first problem, just add down. 7x plus 3x is equal to 10x. Negative 4y plus 4y, those are opposites. Okay, when you add opposites, you get 0. You don't even have to write 0 down here. Okay, and then negative 30 plus 10 is negative 20. Divide by 10. Alright, to get x is equal to negative 2. Now, I don't know if you've just done some substitution problems. I hope you're seeing that this is, in most cases, much faster. Okay, we already have half of our, remember our solution is going to be an ordered pair. X, Y, we have our x. We're looking for our y. So just substitute this back into either of the two equations. I'm going to take negative 2 and plug it into the first one. Okay, so we get 7 times negative 2 minus 4y is equal to negative 30. Now we have one equation with one variable, so we should be able to figure out what that variable is equal to. So now you just have an algebra equation to get through. Negative 14 minus 4y is equal to negative 30. Okay, this is a negative 14. To zero it out, you have to add 14 to both sides. Okay, drop this down, you get negative 4y is equal to negative 30 plus 14 is a negative 16. So then negative 16 divided by negative 4. Negative divided by negative turns it back into a positive 4. Okay, so remember to write your answer as an ordered pair. The ordered pair would be the negative 2, 4. That would be where these two lines intersect one another. Now, you can always do check steps, plug these back in and see if they check it. I'm going to quickly just do that mentally. 7 times negative 2 is negative 14. Negative 14 minus 16. I plugged in the negative 2 here and the 4 here. So negative 14 minus 16 is negative 30, so that's going to check. And you'll find this other one checks too. You'll get a negative 6 plus 16. Negative 6 plus 16 is 10. Okay, so elimination is really straightforward, I think. Should be your method if you're given the choice. Okay, now notice we had opposites already set up for us, and those eliminated right away. We didn't have to do anything. Now that's not always going to be the case. Now this is a problem that we did in the substitution video. Now we're going to do it by elimination instead. When we add these together, 6x plus 4y is equal to negative 2. Well, nothing eliminated, so we're not really ready to add these together yet, okay? So what we have to do is we're going to use a multiplier so that when we add them, they're opposites. Okay, notice you have a 3 and a 1 here, so what we're going to do is we're allowed to multiply both sides of an equation by the same number. Okay, so we're going to multiply everything by negative 3. Alright, so negative 3 times 2x, negative 6x minus 3y is equal to negative times negative is positive 6. Okay. Now I'm just going to rewrite this top equation. You can put it on top or bottom, it doesn't matter. But I'm just going to write it so we can line them straight up. Okay. So notice by using that multiplier, we now have opposites. I get a negative 2x is equal to 6. Okay, very clean. Again, I encourage you to go back to do that by substitution, and I think you'll find elimination is much faster and less mistakes. All right, we're dividing by negative 2. We get x is equal to negative 3, which I believe is exactly what we got the first time we did it. All right, remember that's one mistake is for students to rush through and think that they're done. You're used to solving equations and saying x is equal to negative 3, I'm done. Remember, with a system of equations, you're looking for an x and a y. So this part's the same as substitution, where you're just taking your x is equal to negative 3, plug it back into either equation. Okay, I'm going to plug the x into here and solve for y. So 2 times negative 3 plus y is equal to negative 2. Okay. Use your equation solving skills. 2 times negative 3 is a negative 6 plus y is equal to negative 2. To zero out a negative 6, you have to add 6 to both sides. Get y is equal to a positive 4. Okay. Don't make your teacher hunt around for your answers. Summarize it for your teacher and say x is your solution to this system of equation is negative 3, 4. And I encourage you to plug those back in and double check your work on that. Okay, so the very last thing, well, that's not quite what I wanted. Excuse that, just pull that off. The very last thing I wanted to do is there's one other type of equation we haven't talked about. So this is in standard form. Let's do 4x minus 3y is equal to 11. Mr. Calzin, you have the worst handwriting. I know. One of these days I'm going to get a really cool high-tech pen so I can write better, but just keep bearing with me. Alright, now what happens when I add these together, nothing's going to cancel. And you'll notice if I try to do a multiplier, like what can I multiply 3 by to get a negative 4? I'd have to use a fraction. What can I multiply 2 by to get negative 3? I'd have to use a fraction. Be big one fraction mess here. So, there's a concept of being able to multiply both equations. Okay, so what if let me do this in red. Okay, what if I multiplied this top equation by 2 and the bottom one by 3? Okay, so what I'm after is 2 times negative 3 is going to be negative 6, and 3 times 2 is going to be a positive 6. So that'll allow me to end up canceling those. Okay, so we'd have an 8x minus 6y is equal to 22. And then you get a 6x. Oh, I'm sorry, I can't even multiply. 3 times 3. 9x plus 6y is equal to negative 39. Alright, now by using a multiplier to both equations, now we can cancel, add the equations together. 17x is equal to, the difference between these two numbers is 17. The larger value is negative, so you get a negative 17. Divide by 17. X is equal to negative 1, and then continue on with this problem like we have all the others. Take negative 1, plug it back in. I encourage you to try that. You'll find that this is going to be negative 1, negative 5. Okay, So 3 situations, sometimes they cancel immediately, other times you have to use 1 multiplier, and sometimes you have to use 2 multipliers. Hey, Mr. Caslin, why did you eliminate the y's instead of the x's? You can do either. I could have multiplied by a -3, which would have given us negative 12x. And I could have multiplied here by a +4, which would have given us a 12x. And those would have canceled when I distributed those all the way out. Alright, good luck. It's a video, so you can watch it a couple times if you need to, and there's lots of other good videos and online resources that you can search on. Have a good day.